All right, hello there, geometry giants. Today we're doing constructions, and we're going to show through constructions some of the theorems and rules that we've been using and that we've stated in some of our previous lessons. We're going to show how that works. Now I'm going to do the best I can to show you this on the smartboard through a video. It's so much easier doing it live and pen and paper, but we'll see how it goes. All right. So in lesson number 8, what we did is we learned that if a diameter bisects a chord or a radius bisects a chord, then it's perpendicular to the chord. That means if we have the perpendicular bisector of any chord, that segment, the perpendicular bisector, has to pass through the center of the circle. So if we have to locate the center of the circle, this is our first construction, to find the center of a circle, what we're going to do is take our straight edge, draw in a chord, any chord, draw a chord, any chord, doesn't matter. And then you're going to bisect it. You're going to create the perpendicular bisector of that chord. So there's my chord with my straight edge. I'm taking my compass, if I can grab it. Take my compass and do the perpendicular bisector of my chord. So to do the perpendicular bisector, we put one needle on one end point, mark arc above and below both sides of that line. Switch my compass to the other end point, and I want to find where the arcs intersect. If they don't quite meet up, then I just go back to the other side and do it again. So then I take my straight edge, line it up with the points of intersection, and this would make a diameter. So the perpendicular bisector of my chord has to pass through the center of the circle. So that's my diameter. So just repeat this same process, draw a second diameter, and we will get exactly where the center of our circle is. Now another option would be to bisect our diameter. Now if we bisected the diameter, we would get a second diameter. And make sure this is open more than halfway. So I can either draw in another chord on a different location, or I could bisect the diameter that we just drew in. If I bisect the diameter that we just drew in, I'll just get another diameter. And it's okay to have two perpendicular diameters. And then I'm going to connect those with my straight edge. But in my drawing program, I just have a program that will draw straight lines for me. So where the two diameters intersect is the center of our circle. Okay, so there's the center of your circle. Now, if you're asked to inscribe a rectangle, you can do the exact same construction, only to create the rectangle, you would connect the four endpoints of your diameter. Now, this is more specifically a square, but a square is a rectangle, so that would count. If you had to inscribe a rectangle, you just need two diameters. Any two diameters will create a rectangle inside your circle. So we could do the same construction that we just did. Oh, look at this, construction number 2. Construct an inscribed rectangle. If only I had known that was coming next, I would have saved us time by doing the same construction. Oh, wait, just do what we just did. Okay, so if you have the center of the circle, then that makes it so much easier. Just draw any two diameters, connect the four endpoints. If you do not have the center of the circle, then that's what we have to do first. We have to locate the center of the circle by taking any chord, bisect that chord, and that'll get us moving and grooving on our way. So let's get this center found. Hopefully you're doing this. I'm just kind of talking just to fill in that blank empty space. You guys might even have music on. I don't know, because I'm not there. Do that from both endpoints. This will create my first diameter. Now what I'll sometimes do when I draw my segments here is I'll have the outside portion of my segment, I'll use like a dotted line. And then once I hit the circle, then I'll draw the solid line. Because I don't really need the secant that goes in and outside the circle. I just need the diameter that's inside the circle. But this helps me line up and show my accuracy. So if I put the dots here, like a dotted line out here, it would show the person looking at my paper that I did in fact use the straight edge all the way out to the intersection of the arcs. That way I get points for accuracy. Now, if I want to inscribe a rectangle, I need 2 diameters. I have 1 diameter now. I can either bisect this diameter to get my second diameter to do what we did in the first construction. Now that would make a square, but a square is also a rectangle, so it would totally count for this question. Or I can just take a different chord somewhere else, bisect that chord, and then that would lead me to my point of intersection, giving me the center of the circle. But it would also give me 2 diameters. And to draw a rectangle, all I need is the intersection, I'm sorry, not the endpoints of the 2 diameters, because that would make a rectangle. Rectangle has equal diagonals, and my 2 diameters would be my 2 equal diagonals. Almost there. There we go. So now my rectangle will be found by connecting the endpoints of the diameter. So where my diameters meet my circle, I get my rectangle. This one's not a square, but that's okay. Rectangle is a rectangle, and that is a rectangle with 2 equal diameters as the diagonals. And then if I needed it, I know the center of my circle now as well. Number 3, construct a square. All right, so I don't think we need to go through all this again, but what you're going to do, since we know the center of the circle, what you can do right off the bat is just draw a diameter. Do the perpendicular bisector of that diameter to get a second diameter perpendicular to that one. You would do the construction though. You as a student would do the construction. And then once you have a pair of perpendicular diameters, you could make your square. So you would draw in any diameter first that goes through the middle, construct the perpendicular bisector to get your second diameter, and then you can connect the endpoints to make your square. What if the center of the circle is not given? Well, then we're going to have to first put in any chord, bisect the chord to get a diameter to start with, and then we'll bisect that diameter to get our perpendicular diameters, which would then create our square. All right, so we would do the perpendicular bisector of the chord to get a diameter, then do the perpendicular bisector of the diameter, and then connect the 4 endpoints of the 2 different diameters. Okay, next, construct a line tangent to the circle through a point on the circle. Back in one of our previous lessons earlier on in the unit, when we were doing the equations of lines, we learned that a tangent line touches the circle exactly once and will be perpendicular to the diameter or radius that goes to the same point of tangency. So when the radius or the diameter touches the line at the same place the line touches the circle, the radius and the tangent line form a right angle. So what we have to do first is draw a line connecting the center and the point and extend that line to outside the circle. In other words, we are going to draw a secant line from the center through our point where the tangent line is supposed to touch. Okay, so that is step one. Step two is construct a line perpendicular to the line we just drew and passing through that point on the circle. To do this, we haven't done this in a while, so you're going to put your needle on the point of tangency. You're going to mark equidistant arcs on both sides of that point of tangency. Then we're going to use those points as endpoints to make a perpendicular bisector. So I need to make sure that my compass is open more than what I just used. It has to be open more. Mark arcs on both sides of our line. Then switch to the other intersection points. And if the planets and stars are in alignment, my line will go through my arc intersection points and touch the circle. I guess I should be specific. We were asked to construct the line, so I want to throw arrows on the end of this. And there we go. Our tangent line is perpendicular to our radius at the point of tangency. If I extended this longer, our tangent line is perpendicular to the diameter at the point of tangency. So we just made the diameter into a secant by extending it, and then created a perpendicular line at the point of tangency. So pause the video, try again. So it should look like that. All right, now we're going to create a tangent line from an external point. So our point now is not going to be on the circle, but a point somewhere off in the distance. And we're supposed to be able to create a tangent point or a tangent line from that extended point. So the way to do this, well, let's first give you a visual. When we're done, we should end up with like a tangent line that looks something like that, or maybe another one down here that looks something like that. All right, that's what we're going to create. But we're going to do that using nice, accurate tools. All right. Okay, so step number one is to connect the center of the circle to the extended point where our tangent line is going to come from. So you're going to connect the center of the circle to the external point. Step two, you are going to construct the perpendicular bisector of that segment that you just drew. So I'm going to do the perpendicular bisector of the segment that I just drew. Hopefully my compass will open far enough. I think this will work. All right, so the perpendicular bisector there we go. So that is the perpendicular bisector. We are going to use the point of intersection between our first two lines. We're going to use the midpoint that connects the center of the circle to our external point when we just did our perpendicular bisector, we found the midpoint of that segment. We are going to use that as the center of a circle, a new circle, a second circle that we are going to create. We just generated a point that is equidistant from both the external point and the center of the original circle. We are going to create a new circle using that point, and our radius is going to be to the center of the circle, which would also match to our external point. Okay, so we are going to draw this circle. Once that circle is drawn, we can now use our straight edge to connect the intersection of the two circles with the external point we had to start with. Connect those two, and that will be our tangent line. Now, if it's going to be a tangent line, I want to put an arrow at the end. We could also do a second tangent line on the bottom by connecting the other intersection point of the circles. So we end up with two tangent lines coming from the same external point. Now, let me explain why this works. We learned that when a tangent line meets a circle, it is supposed to make a 90-degree angle. And this, what we're using here is Thales' theorem. So if I put in or connect where my tangent line meets the circle and draw a radius from that point, what I've just created here, I'll show you, is an inscribed angle on the circle we created, on my pink circle. That's an inscribed angle that intercepts a diameter. Now the inscribed angle is half the intercepted arc. Because that inscribed angle intercepts a diameter, the intercepted arc is half my circle. So if the arc is 180 degrees, then the inscribed angle is 90, which means we created a line that touches a circle and is perpendicular to the radius. That means it's a tangent line. Okay, that's basically Thales' theorem. We created Thales' theorem with the new circle that we did. Okay, so our inscribed angle is half of our 180, so it's 90 degrees. That confirms that my tangent line is perpendicular to the radius. Try it again. Oh, sorry. I guess we're done with all the proofs. Now it's you go practice. Problem set. Sweet. All right, under 20 minutes. So rewind and rewatch any one of those that you need. You can go to, if you notice, you can go to mathopenref.com and look up and see these constructions done again, or rewatch my video. Or if you think you got a good grasp on it, just go do it yourself. Okay, so we'll see you soon. Practice, practice. Take care. Bye.